So, good afternoon, everyone. My name is Shubhankar Bonik, and I am a PhD student now. And here I am presenting my master's thesis. So, this research was funded by USDA, and today I am going to cover these topics. This is my agenda, and here we go. So, basically, hydroponic system is a method of growing plants without soil, and here we use nutrient-rich water solution. So in this case, plants are positioned in such a way where they use perlite or coconut coir. Through them, they absorb the essential nutrients for their growth. So there are two types of hydroponic system, which is active systems and passive systems. In the case of active and passive, the main key difference is the uses of electricity. So in active system, we use electricity for rotating the nutrients throughout the plant's root, and for this we use air stone, air pumps, and other stuffs. For passive system, we don't do that. We only set the plants on top of the nutrient reservoir, and the plant's root are submerged into the nutrient solution, and through this they absorb the nutrients. So for this research, we use Kratky method, and which is a passive hydroponic system. As I already explained how Kratky method or passive system work. So as you can see in the figure 1, so the plants are suspended, the plant's root are suspended into the nutrient solution, and through this they are absorbing the nutrients. And there is one catch, which is we never completely full like the refill the nutrient reservoir 100%, because we always keep a aeration zone which is required for plants root development, this oxygen level. So that's why we always do that. But one more concerning thing about in hydroponic system, this is definitely important. Hydroponic system has so many good advantages, but there is one disadvantage, which is there is no additional supports in hydroponic system when you are growing plants. And sometimes I also experience this, like the plants, the fruits yields are not proper size and shape. There is no additional supports for plants. So here comes the root endophytes by trichoderma, which is trichoderma is a endophytic fungi, and which we most time we found it at rhizosphere vicinity. And this trichoderma has like so many strains, and both of these strains has different attributes to the ecological things. And then this trichoderma strains is very easy to find out because of its morphological characteristics, which is a bright green conidial pigments and rapid growth, and of course the repetitive branched hyphae. Now, trichoderma fungi in hydroponic system. So here there is already so many paper published on this topic, that how trichoderma improve the plant yield and other factors like stresses and other things in soil system. Yeah, we already know this. And here I'm also showing one of the in the figure 3, you can see the confocal laser scanning microscopy, where the red dots are representing the cucumber root cells, and the green dots are representing the fungi, which are at the point A, you can see the plants with the roots, the fungi just attached, and the point B, you can see they start doing their colonization, and plant C, you can see their hyphae already penetrate the epidermal cells of the cucumber roots, and through this way they helps the plants to absorbing nutrients. They also give them a additional support and boost up their growth. Now, for this research, I use Corchorus oletorius, which is called jute leaves, and it's an ethnic crop. That means it's not grow in USA, but these jute leaves are very popular in other continents country, and it has so many different names also, like jute mallows, Egyptian spinach, and molokiatu. So it is a tasty edible green vegetables, and it has a enormous potential of nutritional attributes, and then it's like hot weather to grow. So here comes the research goal and objectives. The overall goal of this research is to evaluate the growth and development of trichoderma treated jute plants grown in two conditions, which is controlled and semi-controlled. In controlled condition, I use greenhouse. In semi-controlled condition, I use high tunnels. And to accomplish these goals, I choose 3 objectives. Here I am presenting 2 objectives. So the first objective is to determine the most effective trichoderma strains, which I am going to use in my passive hydroponic system. And then the other one is to evaluate the growth, yield, resilience, and the phytonutrients contents of trichoderma treated jute plants grown in a nutrient solution, which is 100% and 50%. in a passive hydroponic system. So I will go for the objective 1 first, which is greenhouse study. So for this one, our experimental design was total 11 trichoderma strains and 1 control, total 12 treatments, and we tested this on 2 different plants, which is barley and jute. And for the plant growth parameters on this objective 1, we analyzed the shoot biomass and root biomass. So for the preparation of inoculum, what we do, we grow them in a PDA. We grow them in PDA at petri dishes at 28 degrees centigrade for 7 days. And after that, we collect their mycelial conidial surface by using sterile spatula, and then we use PBS solution to make it a suspension, and then we clear the conidial debris by using glass fiber, and after that we use sonic meter to make it uniform and clear. And the suspension was standardized to 1 into 10⁻⁷ spores per milliliter. So for the barley study, we start growing the seeds in agar in a petri dish in a completely aseptic conditions, and then we transfer them into 16-ounce glass jar under control condition again. And after that, after 2 weeks of growing, of course, so we add 1 ml of trichoderma suspension that as I was explaining how we prepare it. And then after 4 weeks, these uniform seedlings move to greenhouse and with the tubular depot cells, and then after 4 weeks we harvest this and then we record the data. For the jute study, we also do the same. We use sterile jute cells, 50 cell trays with premix, and then grow them in greenhouse for 4 weeks. After that, we send them, we transfer them into medium size pot. We add the trichoderma suspension, and then we wait for 6 weeks for the colonization, and then we move them another big pot, and this is the way we harvest it after 4 weeks. So these are my